Alrighty guys, welcome back to your remote learning experience. This lesson is for Monday, April 13th. And this is Miss Shane coming to you live, wishing you a happy Easter. I'm making this video on Sunday, so it is actually Easter Sunday. So hopefully everyone was able to kind of enjoy this Sunday celebrating Easter or not with their families and just had a great weekend. But right back into it today. We are going to move on to solving some mole conversion problems, okay? So last week we talked a little bit about equalities with different types of units. So we talked about the mole, we talked about molecules, moles of specific parts of a compound, and I think that's going to help us a lot this week when we actually get into mole conversion problems, okay? So this is when the dimensional analysis practice all comes in, because we are going to be using dimensional analysis to convert between units that we are working with, okay? So these are just one-step mole conversion problems, okay? There are multiple-step mole conversion problems, but today we are just going to deal with one-step mole conversion problems, okay? So like a multiple-step problem would be if you don't have a direct conversion factor from one unit to another, you would have to do multiple steps, which we've done before. So hopefully you guys are familiar with this, and this will help you maybe dust off some of the cobwebs. Feel free, if you have any of your old practice sheets, to look at those, because that will be super helpful with the dimensional analysis moving forward. Okay? The reason why we use dimensional analysis like this with converting between the different units we've been talking about, like moles and grams, is because it helps chemists kind of work with and manipulate compounds that are too small to see or count. Okay, so that's why the mole was essentially created, which is what we talked about a couple weeks ago, because it specifies a particular number of atoms and allows us to kind of work with compounds and know exactly how many atoms we have in that compound. All right, and it also allows chemists to predict how much product will form in a chemical reaction. Okay, so maybe you see a chemical reaction and you'll know using dimensional analysis, given this amount of this substance and this amount of this substance, how much product will we actually produce? Okay, that will come a little bit later, but right now we're just going to deal with one-step mole conversion problems. Okay, so there are four basic mole conversions that we are going to be using going forward. You should be familiar with pretty much all of these, and I want you guys, whether it's right now, probably right now is the best time, or a little bit later, place these four conversions on a note card or a sticky note of some sort and keep that sticky note close to your heart. Put it next to your bedside if you have to. Don't let it out of your sight, okay? Because you are going to be using this on assessments that we have, okay? The four basic mole conversions we're going to be dealing with are that 1 mole is equal to 6.02 times 10 to the 23rd particles. That particles could be referring to atoms, ions, units, or molecules. So make sure you write down that whole thing, even what's in the parentheses. Also, 1 mole equals the gram formula mass from the periodic table. So that is the number that's right below the chemical symbol. Okay. 1 mole is 1 mole of a gas at standard temperature and pressure is equal to 22.4 liters. So 1 mole of any gas occupies 22.4 liters of space. Okay? Last but not least, 1 mole of a compound equals X amount of moles of the parts of the compound. So this X refers to the subscript in the compound's formula. So for example, right here, if I have 1 mole of carbon dioxide and I want to know how many moles of oxygen I have, I would just need to look at the subscript that's right next to oxygen, and that's a 2. So for every mole of carbon dioxide, I have 2 moles of oxygen. Okay, so please put these 4 things. If you need to include that example, that's fine too, and same right here with the subscript tip. Put those 4 things on a note card and don't let it out of your sight. Okay? All right, so I'm going to give you kind of 3 basic steps to setting up mole conversion problems. Okay? The first step is to identify what is given to you and what you need to find. Okay? So this is kind of like our dimensional analysis problem. So maybe I give you an example where it's, hey, you need to convert 3.75 grams into kilograms. Okay? So the given is the grams, and what you need to find is the kilograms. So identify those two things first. Okay? Second step is to check your conversions note card to see if there is a direct conversion. Meaning, are you going right from moles to particles? Are you going right from moles to grams? Are you going right from mole of a gas to liters? Because that's going to make it a one-step conversion problem. Okay? The last step kind of is to set up a conversion factor, which is what we've used in dimensional analysis before and what I'm going to be showing you in some examples that we are going to do all together. Okay, so I'm going to do quite a few examples, like 4 or 5. So if you feel like you got it down, you can kind of watch a few and then you don't necessarily have to watch the whole thing. But I am going to go over 5, and I do recommend that you kind of do this along with me and practice with me. Okay? So that's my 5th example. I'm going to go back to number 1. A couple of these cool little whiteboards. All right. So this first problem, is converting 1.84 grams of water into moles of water. Okay? So right off the bat, I can see that what is given to me is 1.84 grams of water. And what I need to find is how many moles of water. Okay? This is when I would go to my note card that I made while Miss Deshane was talking and look to see if there's a direct conversion. Okay? Because the first step was to identify what is given and what you need to find, which we did. Now we need to look at the note card for the conversion factor. Okay? So we are going from grams to moles. Okay? And we know that 1 mole equals the gram or the formula mass from the periodic table. Okay? So what I need to find first is the molar mass of water. And that's going to be from the periodic table. Okay, so I'm going to go to the periodic table quick. Dynamic periodic. I just saw dominoes and I was like, I might click on that instead. But it's okay. All right, so I need to find the molar mass of water. So right now I'm going to count how many atoms I have in this compound and figure out the mass of each of those. Okay, so I have hydrogen and I have oxygen. Okay, I have 2 atoms of hydrogen, and there's technically an invisible one right here, 1 atom of oxygen. Okay, and I'm going to multiply those numbers by their mass found on the periodic table. Okay, so hydrogen is 1.008. I'm going to round that to 1.01. And then oxygen is usually around 16. So I'm going to round up to 16. Okay? All right. So I do those things first. And what I get is that this equals 2.02. And this still equals 16. So when I add those together, I get that the mass of water is 18.02 grams. okay? So this is going to help me set up my conversion factor because now I know that for every mole of water, there's 18.02 grams. Okay, that's all that means. So now I can move on to step number 3, which is to set up a conversion factor. Okay, so what I'm going to do is I'm going to put what's given right off the bat here. And I'm actually before I do that, I'm going to set up a conversion chart. Okay, and that chart is going to look like this. So in the top left corner, you're always going to put what is given to you. Okay, so if I do this again, what's given to me here is I have 1.84 grams of water. Okay, and then your conversion factor goes on these two spaces right here. This space is almost never used, so I'm going to put an X through it, okay? So I'm going to put what I am converting to, the unit I'm converting to is going to go on the top, and the unit I'm converting from goes on the bottom. Okay? So I'm trying to, and this is also the find, okay? The unit I want to find, okay? So the unit I want to find is moles, okay? So I'm going to put moles right here. And the unit that I am converting from is grams, which is kind of my given unit. So I'm going to put that down here. All right, and this is where I plug in my conversion factor, okay? So 1 mole of water is equal to 18.02 grams of water. I don't like how far apart this is. Okay, so now all I have to do is multiply this 1.84 grams of water. I'm going to multiply that by 1, okay? And that will give me 1.84 grams, okay? But then I'm going to divide 1.84 by 18.02, okay? So you're going to multiply these top two lines first, okay? And then you're going to divide by this bottom line, okay? So when I get that, I'm going to do 1.84 divided by 18.02, and that's 0.102. And so my units here is going to be moles, okay, because these grams on top will cancel out these grams on the bottom, and I'm left with my unit moles. Okay, so now that would be my final answer, is that 1.84 grams of water is equal to 0.102 moles of water. Okay, so that was my very first example, and I'm going to do the same exact thing again with a different example. Okay, so this does take a lot of practice, so just make sure that you keep going, and this is the one I'm looking for, I think. Keep practicing, because it'll come a lot easier once you keep practicing. Nope, that's number 3. Number 2. Where's number 2? Maybe this is number 2. All right, this is number 2. All right, so number 2, I am trying to convert 2.6 times 10 to the 23rd copper atoms to moles of copper atoms. Okay? Oh, sorry, I'm just readjusting myself. So, as always, I'm going to start with writing down what I'm given and what I need to find, okay? So I am given 2.6 times 10 to the 23rd copper atoms. And I need to find out how many moles that is. Okay? So, next thing I'm going to do is look for a conversion on my note card that I made. Okay? So, I'm looking to go between moles and atoms, okay? And that looks like number 1 applies to this here, okay? So 1 mole is equal to 6.02 times 10 to the 23rd particles. Those particles could be atoms, ions, units, or molecules. So I'm going to write down that 1 mole is equal to 6.02 times 10 to the 23rd atoms. And that's my conversion factor. And this is what I'm going to plug in eventually to solve this problem. Okay? So I've identified what I've been given and what I need to find. I found my conversion factor, so that's step 1. Step 2, now I'm going to do step 3 and actually solve the problem. So this one was a little bit easier because we didn't need to figure out the mass of a particular compound like we did with the periodic table last time. So now we can just kind of move forward with the problem. All right, so I'm going to set up my conversion table. Okay, remember what you are given is going to go right here. Okay, so that is this guy right there, right? Your units that you need to find, which is the moles, is going to go right here. All right, and the units of the given atoms is going to go on the bottom. Okay, so what I'm going to do, set up this one below. All right, I have been given 2.06 times 10 to the 23rd copper atoms. Okay, so I'm going to write that right here in red. Hopefully it fits. Close enough. All right, then the units I'm trying to find are moles, and the units I've been given is atoms. Okay, and this is where my conversion factor goes, from right here. Okay, so I know that 1 mole right here is equal to 6.02 times 10 to the 23rd atoms. So that's going to go right here. Okay? So what I need to do now is just do this problem out. So first I'm going to multiply the top together. Remember, we don't really need this bottom one right here. Okay? So I'm going to multiply these two values first, the 2.6 times 10 to the 23rd and the 1. And then whatever the product of that is, I'm going to divide by 6.02 times 10 to the 23rd. Okay? So 2.6 times 10 to the 23rd times 1 is just 2.6 times 10 to the 23rd. Okay? But now I need to divide 2.6 times 10 to the 23rd. Let's see if I can do it up here. I'm going to erase this really quick. So it's going to be 2.6 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Okay? And my unit is going to be in atoms. Okay? So I'm always going to take, my unit is going to be in moles. Okay? So I'm always going to take this unit in the top right. That's going to be my unit for now. Okay? Because these atoms right here and these atoms right here cancel out. So I'm left with moles. Okay? So if I do that math out, all right, you can use a calculator if you need to. Make sure you plug in the exponents. But since I have 10 to the 23rd right here and 10 to the 23rd right here, these actually kind of cancel each other out because they're just such large numbers. So I can actually do 2.6 divided by 6.02, and it looks like I get 0.432 moles of copper atoms. Okay, I'm going to show you that on a regular calculator. Here we go. All right, so I'll use this calculator right here. Looks like. Oh, so I'm doing 2.6 times, where is it? Is it this one? I'm sorry, I'm not a math person. Oh crap, no. How do I do that one where it's an exponent? Nope. All right, hang on. Bear with me for a sec. I'll get this. Oh God. I think I'm looking for a scientific calculator. Oh, this is the same thing. All right, well, I'm going to try this again. 2.6 times 10 to the 23rd. Aha! I got it. Divided by 6.02 times 10 to the 23rd. Oh God, did I do my thing wrong? Oh my gosh, this is a disaster, isn't it? Please don't judge me for this. Nope. 0.6 times. Oh crap, I forgot to do parentheses. We're gonna get this, okay? Like, Mr. Shane, you are the worst. Yeah, I know. Thank you. To the 23rd divided by 6.02 times 10. Yes, finally. Got the same answer. 0.4, around 0.432. Okay? So, even though I didn't include the exponents in my calculation, still got the same answer. Okay? Because these kind of cancel each other out. Hopefully that didn't confuse you too much. All right, moving on to the next example is number 3. This looks like it could be number 3. Yes, it is. Okay, so I am trying to convert 1.84 liters of what looks like hydrogen sulfide, or hydrogen sulfide gas at standard temperature and pressure to moles of hydrogen sulfide gas. Okay? Right away, I'm going to do my given, and I am given 1.84 liters of H2S. I'm going to write gas like this in parentheses. I need to find how many moles that is. Okay, so that was step number 1. Step number 2, look at my conversion note card, and it looks like any mole of a gas at standard temperature and pressure is equal to 22.4 liters. Okay, so I'm going to write that down below. So I have a gas, and it's also at standard temperature and pressure, and I know that that equals 22.4 liters if I look at my note card that I had. Okay, so that was step number 2. Step number 3, time to set up that conversion. Okay, so my given is going to go into the top left corner. Remember, we do not care about this right here for now. All right, so my given, top left corner, 1.84 liters. Okay, then I'm going to put my conversion factor in the top and bottom right hand spaces. Okay, so I'm going to put the units that I'm trying to find on the top, which just happens to be moles, okay, because I'm looking for moles right here, and this is in my conversion factor, so I'm going to put this one on top. All right, gas is equal to whatever unit, so whatever the conversion factor is equal to. So 1 mole of gas is equal to 22.4 liters, okay? So I'm going to put 22.4 liters on the bottom. Okay? So that's kind of like my given unit, all right? And that's going to go on the bottom, so eventually these two can cancel out, all right? But first, I'm going to multiply the top boxes, so 1.84 times 1 is 1.84. And eventually I'm dividing that by 22.4 liters. Okay? Actually, I'll leave this for now. All right, and my unit at the end is going to be moles, okay? So if I do 22.4 1.84 and divide that by 22.4, I get 0.082. And that's going to be moles of the hydrogen sulfide gas. Okay, and that would be my final answer. Boom. Easy breezy. Okay, so I'm going to continue doing some more examples. If at this point you got it, despite my babbling, I don't know. Keep going, and or don't keep going. But if you are still confused, want to do a few more examples just to get some more confidence, then feel free to stay on. Okay. So number 4 is 2.85 moles of alcohol, and I'm going to try to go to moles of hydrogen, okay? So you might want to stick around for this one because this one can look a little confusing, okay? So first I'm going to do my given, which is 2.85 moles of alcohol, C2H5OH. And I am looking to find how many moles of hydrogen that equals, okay? So this might seem confusing at first, but I'm going to look back at my note card, and it looks like I'm going to need number 4, okay? Because number 4 says that 1 mole of a compound is equal to X mole of the parts of that compound, okay? Meaning that we're trying to look for the subscript here in the compound's formula. So like the example I went over with earlier, 1 mole of carbon dioxide equals 2 moles of oxygen. All we need to do is look at that subscript, okay? So I'm going to look at this compound, and I'm actually going to count how many atoms or how many subscripts of H I can find, okay? So there's technically an invisible 1 right here, all right? So there's 5 hydrogen right here. There's also 1 right here. So I just need to add those together, and I actually have 6, okay? So that means my conversion is going to be for every mole of alcohol, I have 6 moles of hydrogen. Okay? So this is my conversion factor. So 1 mole of the whole is equal to X amount of moles of the part. Okay? And we found that alcohol has 6 moles of hydrogen. Okay? And so this is going to be my conversion factor I'm going to use in this problem. All right? So, per usual, that given value is going to go into the top left-hand corner, 2.85 moles. Okay, whatever unit I'm converting to is going to go up top, and so it looks like I'm converting to moles of hydrogen. Okay, this is the unit I'm converting to, so I'm going to put it up top. The unit I'm converting from is moles of alcohol. Okay, so that's going to be my unit on the bottom. This technically is C2H5. Oh wait, I have to sneak that in there. Okay, and this is where I put in my conversion factor. Okay, so 1 mole, or my bad, ignore what I just said for a sec. That means 6 moles of hydrogen atoms, so I'm going to put a 6 right here, is equal to 1 mole of alcohol. Okay, so I'm essentially just transferring this conversion factor and organizing it into this space. Okay, so if you need more help with having to set this up, please just let me know. Okay, I get that they can be confusing sometimes, right? So what I'm going to do is I'm going to multiply the tops as always, and then I'll divide by the bottom. So first I'm going to do 2.85 times 6, and that's 17.1. Oops. All right. And then I'm going to divide that by 1. Okay. Remember, my units are going to cancel. Whoops. No. What did I just do? Didn't mean to do that. Yes, here we go. So, like I was just saying, my units are going to cancel from the top to the bottom. Right, and I'm going to be left with moles of hydrogen. So my final answer is that 2.85 moles of alcohol equals 17.1 moles of hydrogen. I'm trying to teach. Megan.
I wanted to say hi to your students.
Say hi. We're doing mole conversions.
Hi.
Okay.
It's not a video?
It is. It's a screen recording.
Oh. Sorry, bye.
All right, get out of here. That was my older sister, Megan. We're both home for Easter, and she feels the need to interrupt my class. All right. Last one I'm going to do for today, because I know you're sick of me talking. All right. So, trying to convert 10.2 moles of carbon dioxide to grams of carbon dioxide. So my given is 10.2 moles of CO2. Trying to find how many grams that is. Okay, so we need to set up a conversion factor, but we're looking for we're trying to figure out how many grams of carbon dioxide are in a specified number of moles of carbon dioxide. So we're looking for a grams to moles conversion, okay? So that means we need to look at the periodic table. All right, so first of all, it looks like I have one atom of carbon and 2 atoms of oxygen. So I'm going to put those down first. All right, I'm going to look at the mass of carbon, which is 12.01. That's going to be multiplied by 1. And 2 times whatever the mass of oxygen is, which happens to be 16 rounding up, remember. 16. Right? Multiply those, I get 12.01 still, and I get 32. Okay? I'm going to add those together, and I find that my molar mass is equal to 44.01 grams is equal to 1 mole of carbon dioxide. So this is actually my conversion factor that I'm looking for here. Okay? So I'm going to set up my nifty little table right here. Given is going to go, the given value is going to go in the top left. All right, so that's 10.2 moles of carbon dioxide. All right. Whatever unit I'm converting to is going to go on the top. That is grams. Whatever unit I'm converting from, moles, is going to go on the bottom. Okay, then I just plug these numbers into their appropriate spaces in the chart. Okay, so 44.01 is going to go with grams on top. And then 1 mole of carbon dioxide is going to go on the bottom. Okay, so need to multiply these first two, or these top boxes right here. So if I do 10.2 times 44.01, I get 448.9. No, I don't want to print this. All right. Then I'm just going to divide that by 1 on the bottom. Okay? Remember, these units are going to cancel out, and I'm left with grams. Okay? So that means that 10.2 moles of carbon dioxide is equal to 448.9 grams of carbon dioxide. Okay? So that would be my final answer. All right? Your job today is just to watch this video. You don't have to do anything else. All right? Just watch this and email me with questions. Okay? If you want to try a few of these on your own, that's absolutely fine. I am going to be giving you some practice problems coming up very shortly, probably Wednesday. So all you have to do for now is just to watch this video. Okay? I hope you guys have a great rest of your Monday and make sure that you stay healthy and safe.